Just a minute. Okay. Can everybody see my screen?
Yes, we can, Faith. That's great.
Okay. Good morning, afternoon, or evening, depending on where you're joining us from. My name is Faith Nangila, and I am honored to welcome you to this critical conversation on integrating citizen science data into official statistics. I serve as the coordinator for the Air Quality Monitoring Corp for the Citizen Science Global Partnership, and I am thrilled to set the stage for the conversation today. So our agenda, this is the agenda that we have. We'll be focusing on data gaps, citizen science examples, and FAIR principles and data description to mobilize citizen science data, methods of data integration, and then we'll have a good summary and a Q&A session where we can hear from each and every one of you on what you think about what we have discussed. So I will quickly set the stage for us to understand why we are here and why this conversation matters. So according to the World Health Organization, air pollution is responsible for an estimated 7 million premature deaths yearly. And this is a staggering figure that is one of the reasons why air pollution is considered an environmental health risk globally. Over 90% of the world population, and that 90% population could include each and every one of us here, is breathing in air that exceeds WHO guideline limits. And yet nearly 1 in 3 countries do not have any official air quality monitoring systems in place, particularly in the global south. Now, if you take the context of Africa as a continent, out of the 54 African countries, we have only 36 countries that have continuous real-time air quality monitoring systems. And in this 36, we only have 13. Out of the 36, we have 13 that only have 1 or 2 monitoring stations, and the rest have less than 5 monitoring stations. In Latin America, with a huge pollution scale for the PM2.5, they also don't have enough monitoring stations in most of their urban centers, despite the severe pollution. In small island developing states, there's an increasing air pollution resulting from tourism, shipping, and wildfires, but almost no monitoring infrastructure at all. And in Southeast Asia, you find that there's rapid urbanization that has outpaced the government's ability to measure, let alone regulate air pollution. So the result of this is we have policy that is flying blind and communities that are left in the dark about the very air that they breathe. And the data gap is not just a technical problem, it's also a justice issue because we have communities breathing in polluted air, but without monitoring infrastructure, there is no visibility, no accountability, and no action. So this is where citizen science comes in. Across the world, communities, schools, youth groups, women groups, and informal networks are taking action through citizen science for air quality monitoring. So they are deploying low-cost sensors, conducting air quality measurements, and generating hyperlocal data, which closes gaps where national systems always fail. And these efforts are not just fringe. Globally, it is estimated that over 1 million citizen scientists are actively engaged in environmental monitoring across different disciplines. The UN and the European Commission have both recognized the potential of citizen science in achieving the Sustainable Development Goals, especially SDG number 3 for health, SDG number 11 for sustainable cities, and SDG 13 for climate action. But we are still facing a disconnect because despite the scale of citizen science efforts, very little of this data is integrated into statistical systems. And this is largely due to challenges in data validation, standardization, institutional trust, and lack of clear frameworks for integration. Now, today's webinar is about addressing those challenges, not by asking whether citizen science data is useful, but by discussing how we can make it more usable, trusted, and visible within our national and global data ecosystems. Because when citizens are empowered to monitor their own air, they are not just gathering data, they are demanding change and they are taking action. And integrating that data into official systems is not just a technical upgrade, but it's a democratic act that actually puts power into the hands of the people who are most affected. Now, as we explore integration of citizen science into official statistics, we must ask ourselves, integration to what? Integration cannot mean erasure, and we must aim for international standards that embrace citizen science not as supplementary, but as a strategic and essential. So frameworks like FAIR, findable, accessible, interoperable, and reusable data principles offer foundation and efforts that help citizen science data integration. We have citizen data integration framework, that is the CDIF, that can guide how citizen-generated data enters formal systems with credibility and consistency. But openness must not come at the cost of justice. So as we open data, we must also ask ourselves, how do we protect the people who are sharing this data and their data? And that is where the CARE principles come in: the collective benefit, authority to control, responsibility, and ethics. Especially when it comes to data that is collected from indigenous communities, grassroots communities, and marginalized communities, data sovereignty must be upheld. So as we move into today's sessions, I invite you to reflect on this, that what would it take for a government report on air quality to cite citizen science-generated data alongside official monitoring? And what would it look like if we unlocked the potential of citizen science by not considering it as unreliable, but recognizing it as essential? Thank you so much, and let's dive in into this important discussion. So I will open the floor to Hayoi.
Thank you so much, Faith. This is fantastic. Let me share my screen. Let me go here. Thank you, everyone. Thank you, Faith, for going through the challenges and the potential of citizen science. So today, my name is Haoyi Chen. I work at UN Statistics Division. We're also co-chairing the Collaborative on Citizen Data. Really great to collaborate on this webinar. So I will be talking about citizen data household survey and data integration, since we are talking about data integration. So before I start, looking at the overall global level SDG data availability and the progress and challenges we have, starting from, there has been a lot of progress in terms of data availability since the beginning of 2030 agenda. In 2016, we only had 1/3 of SDG indicator have good country coverage, which means larger than 50% countries have data. This percentage has become 68% in 2024. And then in 2016, we only had 61% of indicators with internationally established methodologies. And now in 2020, we already have 100% of the indicator have methodology internationally established. And then at this moment, we have now 51% indicator have at least 2 data points. So from 2016, we were just talking about one data point. But there still are a lot of challenges. If you look at the chart on the right, it is about those are goals from SDG goals from Goal 1 to Goal 17. Broadly, we can see that Goal 5, for example, gender equality, and 13, climate change, and 16, peace, justice, and strong institutions, all have very low data availability compared to the rest of the SDG goals. And now let's zoom in Goal 11, that has air quality indicator. Less than 30% of the countries have at least 2 data points since 2015 for trend analysis. And there are a lot of disparity across the goals. And then, of course, if we talk about data desegregation, data availability for specific communities or smaller population groups and different population groups, and these are largely insufficient. So these data come from the UN SDG report 2024. So this shows really the progress we've made since 2015, when the 2030 agenda was adopted, and to now, and then still a huge data gap that exists. And really grateful for all the communities that come forward together, including the citizen science community that really helped. So we talk about integrating citizen science and other data into a national data ecosystem. There's no official definition. So in the Copenhagen framework on citizen data that I will say a bit more in the next couple of slides, the latest version published January 2025 this year. There's no official definition of national data ecosystem, but here we really talk about a system that include people, organization, process, and technology, that everyone is part of it, whether it's state or non-state actors that are there to collect, store, share, and analyze data. So citizens and citizen data, that includes both citizen-generated data and citizen science data, are an integral part of the national data ecosystem that work together with other state institutions and private sector and academia. Let me go to my next slide. Now, I am also leading the work on household surveys. So I would like to say a few words about household surveys. And there has been a lot of work collecting data through surveys, and the survey can actually collect data for 1/3 of SDG indicator, according to analysis our group, the Intersector Working Group, has done. And it's quite important and one of the key source on a lot of indicators, for example, on labor, poverty, governance, on health and nutrition. Household survey is very powerful to tell why and how, and then when collected in the right way, and they are really a great source to benchmark other non-traditional data sources, because these aren't probabilistic surveys. And the challenges, of course, is the coverage and accuracy, timeliness, and response burden. Keep getting this, okay. And cost. They are expensive. Opportunities, innovation to improve efficiency. We had recently, a few years ago during COVID, published a paper called Positioning Household Survey for the Next Decade that talk about different innovative approaches that can be used to improve efficiency of household survey. And then the community really calls to work with everyone, including the citizen data community, by bringing different sources together. Now, coming to citizen data, and we, as I've mentioned, we have a Copenhagen framework on citizen data. We talk about citizen data, that means citizens meaningfully engage in the production and use of data. So these data can be integrated, could be integrated into official statistics, and there are citizen data that would like to have good quality assured, but as complementary only, they do not want to be part of official statistics, and some citizen data that would like to be part of, not want to be part of the conversation, would like to serve their own purposes. But the framework really emphasized the point that Faith had pointed out earlier, is really citizens having a say on how data and what kind of data they should be collecting, that should be collected, that would impact on their life. So citizen data is about voice, giving voice, empowerment, especially for the marginalized population groups and populations that are suffering from intersectional marginalization. It is about inclusion in data and in the data production, data use, and also inclusion in the data used for policy making. There have been a lot of challenges as we encountered during our work with citizen data. Of course, there are quality issue and partnership, how to build efficient, effective partnership between state and non-state institutions, and how to build trust. Opportunities, Copenhagen framework on citizen data that really set the frame for the scene for at the global level to bring everyone together. And national statistical offices are really, because of the work that we brought to the commission, and also to the statistical commission that gathers national statistic offices, But also NSOs are really getting more into this area that really gives a lot is extremely important for citizen data to be recognized and to be brought into the official statistics. So this is the Copenhagen framework structure. We talk about the concept, the definition, and the principles of citizen data, and then the role of national statistical offices, as this is a piece that's really important for NSOs. And we also talk about enabling environment for sustainable coordination, production, and use of citizen data. The last element of the framework is the implementation roadmap, and how, once we have the framework, what do we do next? So one sentence about citizen data, we really focus a lot on engagement and the participation of citizens throughout the entire data value chain, from the very beginning, the design stage, to the end. When the data are being used to make an impact, the citizens need to be sufficiently and meaningfully engaged and participated in this process. We strongly recommend citizens are being part of entire data value chain, but if it's not possible, and at the beginning of the stage is really important, really at the design stage, to bring citizens in. So this is the operational definition of citizen data in the framework. And in terms of the role of NSOs, and NSOs are really good with data standards and quality and guidelines. So it's very important for them to bring their expertise in, also build capacity and foster partnership. Capacity here means it's actually both. Citizen science and citizen data community also have great strength in many ways, for example, on qualitative data. So how can the NSOs and the other citizen data community help each other? And NSO can also help raise awareness of citizen data's value and advocate for its integration into official statistics. So we can see NSOs as a data steward and trust broker between the citizen data producers and for citizen data and official statistics. Almost there. Couple sentences about collaborative on citizens. So all the great work on citizen data have been really led and guided, spearheaded by the collaborative on citizen data. This is really a partnership that we brought together with 10 steering committee members from different communities, but we also have a large group of members that have been working together to support the establishment or the development of the Copenhagen framework, but also to support the implementation. Here is the implementation of framework. I'm not going to cover that everything, but we're really mobilize resources and partnership, development tools and quality standard or knowledge products, covering various aspects is listed on the screen, and also advocating for citizen data where they're to really encourage the more production and use of citizen data and foster knowledge exchange. We are going to have our next expert group meeting October 2025. So that's going to be the fourth one. We will be talking about implementation of the framework in Cali, Colombia, hosted by Dane. And then, of course, we're also working together with countries, supporting countries, bringing a lot of great experience at the national and community level to the global level. And at the same time is also, of course, bringing the global level to the local context. With that, just one slide on data integration. It's never really enough to emphasize how important it is to bring all the different data sources together, because one source cannot achieve everything. So how can we bring them together? These are some of the examples we have done, bringing census and survey together, geospatial data, administrative data together. And of course, we're very excited to see citizen science coming into the official statistics and citizen data into that. So the advantage is really to bring a more comprehensive view of the society by only bringing everyone together and all the data sources together. A lot of challenges, different standards, and we all have different languages, and how can we work together? And sometimes, and even building models, and has been quite challenging for NSOs, for some of the countries to really start accepting as official statistics. but we have no other choice. It's really out of necessity. And there is a lot of interest in doing this. With that, I think that's my last slide. Thank you so much. Good. Back to you, Faith.
Thank you so much, Hayoi. I didn't get to introduce you actually because I thought you'll do the introduction, but just to add to that, Hayoi leads work on citizen-generated data and data integration at the UN Statistics Division. She coordinates the Intersecretariat Working Group on Household Surveys and holds a PhD in statistics from the University of Florida. So we have to give you your flowers. So next we have Nuria. Nuria is a senior scientist at NILU and coordinator of the City Orbs project, enhancing citizen observatories across Europe. She leads research on sensor technologies, citizen science, and planetary health, and co-chairs the CSGP Air Quality Group globally and in Europe. So the floor is yours, Nuria. You're muted, Nuria.
Yeah, sorry, something needed to be forgotten. Thank you so much, Faith. So I will take also like a little bit on what Faith was saying. We are not here to discuss if citizen science is useful. We are here to talk about how can integrate citizen science into statistics, global statistics, and for policy and air quality management at the global scale. So I will try to, with this, in the last years, if we look at the last 20 years, there has been an increase in the number of the use of low-cost sensors in research, but also in citizen science. And we have seen how they have been used to detect natural sources as wildfire, volcanic eruptions, and also human-made sources as construction, waste management, transport, household heating, etc. So one of the more exciting applications of the sensors is the application in citizen science, and thus giving people the opportunity to monitor the air quality in their community, basically. And here I want to bring an image, if you see on the top, that's from OpenAQ, a platform that is making a huge effort to collect both reference monitor data, but also air quality sensors on the world and displayed in their platform. And you can see, it's very easy to see that we have a lot of data in Europe and also in the United States, but we have also still many data gaps in Africa or South America. If you look at the picture below, you will see that it's almost more or less very similar, both pictures, although the one from below, it only considers 3 major citizen science initiatives. There's no reference here data, and there are no other community data. There's only 3 major citizen science. This is Purple Air, Sensor.community, and Smart Citizen. And what this slide shows us is the value of having interoperability data. To gather this data, you only need to be using, let's say, 2-3 APIs. I'm pretty sure there's much more data sets of community gathered data around Europe, in Spain, I'm pretty sure of them, and also in Africa and South America. But if the data remains in silos, it is always closed in some, not open for the scientists to be used. It's very difficult to integrate it, and it's very difficult then to get this geographic coverage that we need. Another of the things that is preventing the uptake of citizen-generated data is that we always get this saying, like, the citizen science data is not of good quality. There has been a lot of work in Europe and also in the United States on sensor evaluation, both in laboratory and in field. Here you have some papers ranging from 2017 to nowadays. And here you have 2 pictures of reference stations with collocation of sensors to get data, the accuracy of the sensors. But what is very exciting is the one on the top. This is in Ghana, where they have now set up a full laboratory evaluation and field evaluation of sensors. And the same is happening currently also in India. And this is truly important that the sensors are not only evaluated under the global north conditions, but also that the global south take ownership on this work. In this slide, you can see why it's important also that the sensors are tested. You can see on the bottom, I'm not sure if you see my score, but you can see like this is like a review of many papers evaluating sensors. You can see that many of them, they give us good accuracy when they are tested in lab, but the accuracy has a wide range of accuracy when we move to the field. So then it's really important to know what is the quality of the data that we are producing in order that this is uptaken at a global scale, and also like building trust in the data. This is the reason that we have now generated a framework to validate. We call it crowdsourced data, or can be because we don't know like if all has been generated by Citizen, but most of it has actually been generated by Citizen. And what this framework we have tested now in Europe. And what you can see, we left some units outside for validating the validation and correction framework for citizen-generated data. And then, sorry, got like some, and we could see that it has been an improvement in the data, and then we can say like what data is. Well, what if you want a high quality data, then the data is flagged and people can download it and use it with a high level of trust, and at least they know the quality. This is one example of the data that has been used after validation. Again, this is in Europe, and then the data of the sensors collected by the citizens has been merged with the Copernicus atmospheric model and also with satellite data. And we have seen that the air quality maps improve their accuracy after ingesting citizen-generated data, because they provide knowledge that it's not in the current systems. Some examples, again, in the Nordics where I work. This is a local citizen campaign to understand the pollution from household residential wood burning that is used for household heating. And we could see that by just deploying few sensors, we could improve very much the air quality model and then give feedback to the authorities to improve the stoves in this area. Also, other applications of citizen science is the use also of mobile monitoring, not only static. This is examples of sensors that people can mount on their bikes and also on their backpacks. And this type of mobile monitoring give us a lot of information on human exposure to air pollution, and also bring some spatial statistics that is not possible to gather with other type of data. Another big topic is not only the odor, but also citizens have been monitoring their indoor exposure. Again, you can see in the map, this is a review of 60 studies, that most of the studies are happening in Europe and North America, and still we are missing many studies on indoor pollution in the global south. So like a small slide just to say that there has not only sensors, but also since long ago, citizens have also been used what we call passive samplers. They give you an average over weeks or months of usually for nitrogen dioxide in this case, and this can be actually of very good complement to sensor data. Some of the challenges that we try to overcome is having data of non-quality, also the limited interoperability across networks, creating more fair data. And also one of the challenges having, if we want to have these trends that Haoyi was mentioning, having long-term engagement and long-term data collection. This is a review paper, and what you can see here is that most of the current campaigns and when citizens are measuring is between 6 and 12 months or 12 and 24 months, but there are no longer support for longer campaigns that, for example, can be if a sensor is broken and then is maybe not replaced, or if a financed project ends, then the citizens are not longer monitoring because they don't get any support. So it's important also to get these long-term field campaigns if we want to integrate the data from citizens. Sorry. So in order to do that, a little bit of propaganda. In the City Ops, we are generating a cookbook and toolkits. They are open science. They are available in GitHub, and they are co-created with existing communities. And we would love this to be a repository of experiences, stories, and guidelines that everybody can create and also use. And we are testing it now here in Europe with 85 cases, and we will be willing to also open this to other communities worldwide. Thank you.
Thank you so much, Nuria. Your examples have really brought life to citizen science potential. Thank you so much. So next, we will have Marty and Simon, who will take us through FAIR principles and data description to mobilize citizen science data. And Simon Hudson has served as an executive director of CODATA since 2013, a leader in research data policy. He recently coordinated the World FAIR project and now leads its successor, which is World FAIR Plus, focused on advancing the cross-domain interoperability framework, CDIF. Marty works in CODATA as a project portfolio manager, overseeing project alignment with CODATA's mission. With experience from RDA Europe and EGI Foundation, he specializes in policy and IT support for innovation in research infrastructures across Europe. So the floor is yours, gentlemen.
Thank you very much, Faith. And both Marty and I developed these slides that we'll present over the next 10 minutes, but I'll be doing the speaking in the presentation. And thank you very much for the introduction, Faith. So Faith and Haoyi have outlined the data gaps and the need for incorporating citizen science data. Nuria showed the benefits in terms of knowledge of that. And now we'll talk a little bit about how we can make that easier to do. So the application of the FAIR principles, and in particular, the cross-domain interoperability framework, which Faith has mentioned in the introduction. I'll very briefly introduce the organization that Marty and I work for. This is CODATA. The full name is the Committee on Data of the International Science Council, but we're a freestanding organization. We exist to serve the mission of the International Science Council, but we're an organization in our own right. We work with many partners globally, the ISC and its members, our members, international organizations. But above all, we prioritize work on data policy and implementing data policies to advance science, and also on technical issues to advance interoperability and the usability of data in all areas of research. And so our vision is of a world in which science is empowered to address universal challenges through transparent, trustworthy, and equitable use of data information. And so that means the FAIR principles, and also, as has been mentioned, the CARE principles. Now, I'm going to focus on the FAIR principles. I'm not going to talk about the CARE principles a great deal, because at this moment in time, we're primarily concerned with those issues of usability and data integration, combining data from different sources, including citizen science and statistical data. And the FAIR principles provide a guide and a set of principles and an incipient toolkit to help us do that. FAIR principles were published in 2016. They've been extremely influential. Look at the number of citations, whether we believe the Nature journal in which they were originally published or Google Scholar. Either way, that's a lot of citations and a great deal of uptake. And one encounters the term FAIR a great deal. I do hope that most people on this call are at least broadly familiar with what is in the FAIR principles, that data and the accompanying metadata and semantics should be findable, accessible, interoperable, and reusable. And on that slide, there's a gloss of what that means specifically for each of those principles, and there are more detailed principles there. Our past president, Barrett Montz, hosted the workshop in Leiden in 2014 that led to the FAIR principles, and our current president, Meszek Rosas, was among the authors. I was the chair of a European Commission expert group that developed a report turning FAIR into reality of really how we implement the FAIR principles in the European research space. But what are the FAIR principles for? What do they help us do? And they're a guide to improving data stewardship, but they're principles, not a standard or a manual. And so they need further detail, need guidelines in order to put them into practice. And that's where this concept of interoperability frameworks comes into play. And that's really how I'll introduce the cross-domain interoperability framework. The FAIR principles stress the need to increase machine actionability, the ability of machines of code to work on data and metadata, and above all, to combine them for scientific objectives. And to do this, we need a greater emphasis on metadata, on semantics, and the provenance of data as well, assessments, understanding where the data came from, but also assessments of the data quality, so we know what data to include, what data perhaps not to include. And this is really important at this point in time in 2025, because we need interdisciplinary research, as we've heard from the previous speakers. We need transparency and reproducibility of data sets, of combined data sets and the research that comes from, and we need to be AI ready. And it's also the case that the FAIR principles, the increase, the enhanced metadata and semantics, and we would argue specifically the cross-domain interoperability framework, can be used to help us implement the CARE principles as well. And there's an article from the ARDC, the Australian Research Data Commons, which makes that case. But above all, we need to focus on the I and the R of interoperability and reusability in FAIR. Now, why does CODATA care about this and care about the collaboration with citizen science groups and with UN SACS? On one level, that should be obvious, but we have, as part of our mission from the International Science Council, a mission to address interdisciplinarity and to facilitate the way that science systems, research infrastructures, and the scientists that use them to enable them better to address interdisciplinary research questions. The premise of this is that the major pressing global and scientific human challenges of the 21st century can only be addressed through interdisciplinary and indeed transdisciplinary research that combines data from many different sources with the objective of turning data into knowledge and then into action. The premise of that must always be data in aggregation and integration within and across traditional domains. So for a number of years, we've had a mission to address this challenge and to look at how we implement the FAIR principles, but in particular, how we do so for interdisciplinary research. That we were entrusted by the International Science Council to develop a program. The centerpiece of that program became the World Fair project, which has been mentioned kindly by Faith. And now we're launching we have launched a broader initiative, which we call World Fair Plus. And at the center of that is the cross-domain interoperability framework, implementing that in a set of case studies to advance how we combine data from different sources and across domains. So what is the CDIF? What is the cross-domain interoperability framework? It's an attempt, as I've indicated, to put the FAIR principles into practice and to make a framework that enables us to do that. It starts with the premise that the most important use case is aggregating and integrating data within domains, or in particular across domains. And so it identifies a set of specific functional requirements for that, and then makes recommendations for how to do that. It provides a set of recommendations as well as worked examples and examples in code of how this can be put into practice. I need to be clear that it's absolutely not a new standard. We haven't developed a new standard to replace them all, as the XKCD article, the cartoon indicates there. Rather, we point to existing and emerging good practice, and in particular, domain neutral standards, and describe how they can be used together. So CDIF was published at the end of the World Fair project, about almost exactly a year ago. It currently contains 5 specific profiles covering discovery, access, how to treat core controlled vocabularies, because semantics are extremely important, and a profile on data description for integration. And our colleagues Flavio and Luis will talk about that in more detail. It also deals with universals, which are often connectors between data sets. The point of reference for CDIF and its component profiles is now the CDIF book, which is linked there. And we do invite you to have a look at that in detail. It's a very practical guide for what to put in place to implement the FAIR principles specifically for data integration. Now, it's not the last word. It's one step in the direction of what we need. The CDIF working group is continuing its work, both in working group activities and in the context of a set of projects, which, as I mentioned, we call World Fair Plus. This diagram, I'm not going to go into a lot of detail in the interest of time, but indicates some of the areas of work that we're still exploring. Further detail on semantic mappings and data description for integration. There'll be a lot more work on managing access, and there's also a lot of work on how do we provide the context for data and provenance and processing information. Now I'm going to end this short part of the presentation with mention of a project. It was a cascading grant project from ExFuture. CoData as such weren't involved in it. Those colleagues that work for CoData also lent their expertise to this project. And it gives an example of what we can do with DDI-CDI. So that's the Data Documentation Initiative's cross-domain integration, which is part also of the CDIF recommendations. So why combine social survey data and climate data? What's our motivation for this? We need to respond to these sort of science questions. Do observable indicators related to climate change or local air pollution have effect on climate change concern beliefs? So what this project did was to combine data from the European Social Survey with climate data of various sorts, including air quality data and weather data. And it provided a combined data set, or at least the methodology to create that data set, in a standards-based and repeatable way. And that's really important. We saw from Nuria that data integration activities happen all the time. Really, the importance of this project is to document precisely how that's done so that the data combination can be repeated in principle year on year. And what I would leave you with is imagine the power of this if we combined citizen science data in this way as well. So that's what we're trying to explore in collaboration with colleagues at DDI and in the context of CDIF, the cross-domain interoperability framework. One of the places that we're doing that is in the Climate Adapt project, which is one of a set of projects funded by the European Commission as part of the European Open Science Cloud. There, we're developing data platforms to address climate change and to explore climate adaptation using 3 specific use cases. One on urban heat island mitigation, which includes citizen science data, one on coastal flooding and ecosystem protection, one on the issues caused by shrinkage and swelling of clay soils. And in all of those use cases, CDIF, as I've described it, and its components, and particularly DDI-CDI, is being used for the data integration. And also, we're exploring issues of legal, organizational, technical, and semantic interoperability. And as I say, in that first use case on urban heat, citizen science data will play an important role. And I think that's the end of my set of slides, and I'll hand back to Faith, who will introduce the next speakers.
Thank you so much, Simon, for the great insights on building usable and trusted data. Now, for the next segment, I would like to invite Luis and Flavio. Luis is a statistician at UN. He has worked with national statistical offices and international partners on methodology and capacity development projects, particularly in the fields of economic statistics, data quality, development indicators, and the coordination of national statistical activities for the SDGs. Flavio is an interoperability and data architecture expert with vast experience in the development of standards, models, and reference architectures for data and metadata solutions. For the past 15 years, he has been an active member of national and international committees and working groups, including the UNECE HLG, supporting standard groups, of which he is currently the chair, the DDI Alliance, CODATA, and the Government of Canada. He holds a master's and a PhD in computer science from the University of Toronto. Gentlemen, the floor is yours.
Thank you, Faith. Hello, everybody. I'm going to talk a bit more about CDI. As Simon mentioned, the CDIF and CDI as one of the standards that are implemented within CDIF. And just to give you a bit of history, DDI in general, all the products that have been produced is the DDI Alliance, has been used for a long time, for over 2 decades, for the social, behavioral, and economic domain. So basically, ways of describing data and how things are transformed to different extents by different standards. So there is a whole suite of standards that DDI is covering. And one of them, the most recent one, is DDI-CDI, or cross-domain integration. So this standard complements the other ones that the DDI Alliance have been producing. And it does so by referencing all the DDI products for data collection and management, for instance. So essentially, is a standard, CDI is a standard that links to other standards when the other standards do what the DDI-CDI and the use case needs to do, and integrates also with other domain standards like generic web standards, technologies, and also RDF. So it focuses on multidisciplinary. So that was the main goal when this standard was produced, and also in interoperability. So the idea is that the data sharing and integration becomes interoperable for multiple disciplines. It centers on variables, structures, and datum level descriptions. So basically, these are the building blocks that we are covering and emphasizing on. It allows for descriptions of data sets to make them integration ready. So you can describe data sets at multiple granularities and levels of detail. And in the particular for the CDIF, we are focusing on describing the data sets well enough so that they can be integrated. It provides for lossless, automated, and restructuring of data. So basically, you can exchange formats or structures. So data that is in a given structure can be transformed into others, can be aggregated, and so on. And it supports the description of genetic process flows for provenance and also for this type of transformations that I mentioned. So it provides different levels, different types of syntax representations for machine actionability, and you have a few there. These are the most important elements, the core of DDI-CDI. So on the right-hand side, you have the data description elements. So we have the notions of data sets, data structures, datums, data points, and so on. On the left, we have in yellow the semantics and the representations that this data needs to use and in order to be well described. And at the center, joining the two notions of semantic and representations with data are the variables that can be expressed at multiple levels of granularity, conceptual, represented, and instance. There is a lot to say about this piece, but I'm going to just leave you with that part for now. And you will see a bit how that works in a concrete use case when this gives his presentation. And provenance and also transformations are at the top, is this type of all the elements that we need in order to describe how things change, where are they coming from, and that includes flows, transformations, activities, and so on. In gray, you will see all these different standards that can be linked from the different groups that you see on the screen. So you have SCOS and XCOS. These are very, very common and standards that you probably use in some of them, like schema.org or DCAT. And the idea is that the DDI-CDI is the one that brings all of them together in order to be able to address one particular use case, like for instance, in this case, data integration. So DDI and SDMX are the two main standards in this domain in official statistics. So we choose to start trying to link DDI and SDMX for interoperability for data integration because it's a use case that is very common in this official statistics domain. So we have a large number of use cases, and DDI-CDI can be used as a kind of Rosetta Stone or lingua franca for mappings and integrations, because it focuses on multidisciplinary and the different representations that I mentioned, and they complement these other products. So basically, those three things are the essential pieces that allows us to use CDI in the middle of this integration process. Now, some prerequisites for effective data integration: we have to describe the data well enough. I mentioned that on passing before. That means structure, semantics, and code sets. We need to define mappings between the concept variables and code sets in order to harmonize when possible, but if not, at least to be able to compare and to express how these things that are not harmonized relate. And we need to provide also process descriptions for provenance and for doing all the transformations that we need. So I will stop right here. Luis is going to describe next the use case and more about CDIF. Thank you.
I hope you can hear me.
Yes, Luis.
Thank you. Well, thank you, Flavio, and my colleagues, panelists before Flavio for this great presentations. I will just follow on Simon's introduction of the cross-domain interoperability framework and Flavio's presentation on DDI-CDI. about how we are trying to implement these tools in the work of data integration in the statistics division in the United Nations. And hopefully this will provide some ideas on the similar patterns that could help integrate statistical data with other types of data, including citizen-generated data. So let me move to my next slide. Well, we already heard about the challenges in cross-domain data integration, the multitude of data silos across organizations and domains, and how data that comes in different formats using different standards and definitions, different units of analysis, and also with uncertain or different levels of quality make that integration difficult. The role of metadata, which is often missing or is not structured in standardized manner, compounds the problem. And now we also have to address gaps in the access to technology and capacity for that integration, and the availability of modern governance framework that allow us to deal with multiple actors and in this in the framework of new challenges imposed by new technologies, etc. So the cross-domain interoperability framework that Simon explained we find it's a very powerful tool to make data resources fair across domains, across infrastructure boundaries. And for us, the functions I mean, these are many aspects of it. But for us, we start with being able to understand the structure and the semantics of our data, very much aligned with what Flavio was explaining, to enable the better discovery, better assessment of the quality and the characteristics of the data we want to integrate, to provide the tooling for access, and then implement the integration and the packaging of data sets in usable ways. Pointing to what Simon also indicated, making our data in this nowadays also AI ready. So I would like to stress these recommendations from the CDIF framework. As I said, there are many recommendations and useful guidance there, but I wanted to stress the importance of the ability to being able to express metadata in different formats, to move from one format to another, from SDMX to schema.org, from SCORS to XCORS, and etc., and integrating data that is expressed in different standards using DDI CDI. So to manage the data at the finest granularity possible, finest level of granularity that is possible, to facilitate composability, looking at data in a modular fashion, and also the importance of identifiers that allows to interconnect data produced, maintained, and collected by different entities. So making data integration ready, it means assessing and understanding the data sets, harmonizing the data at different levels of granularity, harmonizing their level of granularity, harmonizing the concepts and the representation, and enriching this metadata with context and with provenance. And we are doing that using the DDI CDI for the case of statistical data, starting with characterizing the way our data is modeled in ways that then can be understood and interconnected with other ways of modeling other types of data. So in our case, for statistical data, we have a dimensional model that is covered by DDI CDI, where we have dimensions, attributes, and measurements. We identify what are the universal dimensions, geography, time, the role that is played by different structural role that is played by different variables in our data sets. So all of this is done initially in the SDMX world, where statistical data is often that is often used in the world of statistical data. But then we translate this to its representation in DDI CDI. And that is what allows this magic then of being able to transform our data set from our domain specific or community specific standards into standards used by other communities. This part, in addition to describing the data, we also need to work on aligning the different elements of the data, aligning the meaning of different data elements, aligning terms that refer to the same concept across different providers, and tracking how concepts are created, are split, are merged, and removed from active use. That's part of the traceability and description of the process. And making these mappings machine actionable, so expressing them in the mappings themselves in machine readable way. And for this, one thing I also wanted to stress is the importance of classifications and vocabularies, which is also part of the CDEF work program. So that in order to be able to integrate the data sets, we need to align different classifications, different vocabularies, and map the global classifications taxonomy to those used by different communities, to community specific or local vocabularies. And these mappings and these vocabularies need to be openly and easily accessible. So we also would like to advocate for the publication of these vocabularies and mappings as linked open data. And we are working on that with several partners. These mappings are fundamental. These mappings allow then systems to automatically or efficiently link to each other, and also allow to leverage these new emerging technologies that we are confronted with today. So the use of enabling the use of AI and machine learning for data integration, for natural language search, for discovery, for data analysis, and also privacy enhancing technologies for secure, verifiable data sharing. And I want to conclude by this point that the data integration also has a dimension of ethics, where the principles of data governance, protecting privacy and ensuring data security, and promoting equitable access to data need to be at the fore. All of this work has been hugely facilitated by the availability of these new frameworks, new ways of communicating across different data communities. So for us, the use of the DDI CDI, for instance, to describe data in ways that allow us to bridge from standards like SDMX to schema.org, for instance, has proven to be immensely valuable. And also the guidance and the general framework from CDEF, I think is very valuable, and I hope we can continue working with other communities using these as our mechanism for enabling communication across data communities. Well, thank you very much.
Thank you so much, Luis and Flavio. That was a powerful illustration of how diverse data streams can come together to tell a fuller story. As we go on with the session, please feel free to type in your questions in the chat or use the Q&A feature. So to synthesize what we've heard and point us forward, I am pleased to welcome Caroline to give us a brief summary and a call to action. She will also be taking us through the Q&A session. So Dr. Caroline is a director of geospatial data science at the University of Canterbury and co-chair of CODATA's task group on citizen-generated data for the SDGs, focusing on the role of geospatial and citizen data in sustainable development. Caroline, the floor is yours.
Thank you, Faith. Would you be willing to share the slides from your side, Faith? For some reason, the permission won't allow me right now. Yeah, so we just wanted to take a moment to bring this back together as a group and give you all an opportunity also to share your thoughts and interact with the speakers. So we have a few points that we want to summarize with you all, really emphasizing how this is an international effort. We want to see contributed data from the community be brought together and reflect on what we can do to make that happen, following the FAIR principles and the CDIF framework to facilitate this kind of global monitoring, and really aim for community agreement around standards. And there will be follow-up workshops as part of this group to help to come together on what these standards would look like within a citizen science context, but then also especially for air quality. So there will be a link put in the chat by one of my colleagues that you can put an input about what your thoughts are in this space, and can allow opportunities to come together. So as we really want to emphasize to you all with this call of action, that we need to reflect on what we can do first internally to our organizations and to the data that we work with, the degree to which we are following the FAIR principles, and whether there's efforts that we can take to help to integrate air quality data and bring it to the global community. And we want to connect and share these efforts with our community so that we can help facilitate and help to explore ways that we can collectively come together. So if you're able to look at this survey link and fill out that in the next time period, that would be helpful. Please also use the chat if you have any questions, or if you'd like to turn on your mic and ask a question at this time. We will open up the floor at this moment. Are there any questions to kick off?
Let me, Caroline, let me open the mic for everybody so they can start. I think it's.
Oh, thank you for that.
Yeah, I think it's not. Let me do it now.
In the meantime, though, is there any from our speakers? Are there any comments that our speakers have now, having heard the group? I know you can also use the chat for anyone on the call. All right, I see we have a taker. So there's a question from Arafan Gregory on, could we describe an agreed set of concept definitions for use across citizen science communities? These could follow the CDIF guidelines for controlled vocabularies. Absolutely, this is something we as a community would love to see. Would any of the speakers like to start to address this? I think Simon, did you want to jump in?
Yeah, I mean, thanks very much, Arafan, for the question. This is something that we've been discussing with you, Carolyn, and with Haiyi, about specific variables in citizen science data that we can describe, and in particular how those variables can contribute, or how the data that relates to those variables can contribute to SDG indicators. And it's that particular sort of approach that I would be very interested in, and in understanding, perhaps from Haiyi and from Nuria, how we can go about that. I had a sort of related question as well, which is that Nuria showed us examples of data integration. And of course, data integration happens all the time. But I'd be interested in understanding from Nuria and the projects that she's involved with, whether the approach that's been described by myself, but then in more detail by Flavio and Luis, whether that could be of interest, and whether we can initiate a conversation about how we go about that technically.
Yeah, I can also I can say, like, from my experience, this is really needed. You know, like, and I'm not an expert on semantics and interoperability myself, right? But I work with data and with data integration and data validation, and I try always to collect the largest data sets as possible. And just to say an example of how useful it is, it's like we spend hours, and sometimes we just give up on how because we don't know what the people is measuring, because the variables are not described, right? So just to know, like, okay, right, like, it sounds so simple, right? It sounds so simple, but just that already makes you, because there is data, but if you don't know what variable, what unit this data is being collected, you know, like, you're really lost. So I think, like, guidelines on, okay, these are the more standard vocabularies. If you link to that, then people understands, you know, what are you measuring, and I guess, like, just to make it as easy as possible, right? Like, yeah, I think that's a little bit my experience, that we truly need it. We truly need it. Yeah.
Absolutely. Yeah. So it sounds like it's one of these things that across the world, people are struggling with on how to integrate data from citizen science, from air quality. And we do need standards to help to facilitate that process. So that's one of the goals that we hope to come together with as a global community, as a partnership, to help to structure these conversations, these guidelines for what it means for these communities. So we have another question. So the question is if there's any interesting software tools that helped with the presentation. And I guess I'll stretch that a bit, of maybe not just with the presentation, but in the process of coming together with data integration. If there's any comments that speakers want to make on useful tools.
Well, I can comment. One of the things in these toolkits that I was presenting is that we try to make a collection of tools that have already been created and are available and have been used maybe by other community projects. So because, yeah, there are many tools outside, and it's difficult to find sometimes a tool that really meets your expectations, also the level, if you know programming or not know programming. But yeah, that's in the data analysis, and I see Simon has something to add there.
Yes, so DDI-CDI is a relatively new standard, but it's based upon, as Flavio explained, it's based upon some long-standing concepts in the DDI suite of standards. As part of, in response to, or I should say, building on the project, the EOSC Future project that I mentioned, and as part of the World Fair project, our colleagues at SIG developed a tool for creating DDI-CDI compliant metadata. Those colleagues are actually on the call. I noticed Benjamin Boyster and Hilda Orton are both on the call. If they were willing to unmute and describe that tool, that would be very helpful, perhaps for the person that asked the question. If Benjamin or Hilda don't mind me.
Hello, do you hear me?
That way.
Yeah.
We can hear you, yes.
Yes.
Okay, we have created one tool that is capable of importing CSV files, SPSS or data. and then converts both the metadata of the tables, like the variable metadata, variable names, labels, types, and code lists into CDI. And you can also add a second option to convert the first data rows into CDI. There's an add-on option if you also want to document the data itself. Yeah, it has some CDI specific options. You can set roles for the variables. It can be like an identifier variable or a measurement. And yeah, then you convert it into a CDI and download it as JSON LD. It's an online tool, so you can test it out, and I will post the link to the tool to the chat. And if you have any questions about the tool, please, approach me. My email is also within the tool, so you can find the contact address.
Yeah, I put the link in the chat, Benjamin, and I would also like to add one comment to what you said, because for example in air quality there are many variables, like for example what EEA calls the metadata file, right? There are lots of kind of variables that are related to the measurement stations, and they in CDI they could typically be marked as attributes. So not the measures themselves, but really measurements about something else. So yeah, that is an advantage that the DDI CDI has. So if you combine the so-called metadata about the stations with the data themselves, that is a useful way to distinguish between the measures and these attributes.
Thank you both. That was very helpful context. Hao Yi, I see you also shared something in the chat. Did you have a comment on that?
Yeah. I mean, a few things. One is about releasing metadata. I think that's really a universal challenge across all. Official statistics, non-official statistics, is just not a very common practice. My colleagues from UNSD has been working on the guide on metadata for different sources. And then in our latest handbook coming up on household surveys, UN handbook on household surveys, we focus a lot on metadata through the different stages from the beginning, designing, data collection, and they kind of pass on the metadata all the way throughout the GSBPM and the end, what to release to the users. In terms of the tools, so we have a platform that does the provide all the literatures and methodologies for smart estimation, which is a modeling technology and modeling tools to bring a survey and another sources together through models. But one thing we have always been struggling is every indicator that you're working on relies on a set of unique models. And you have to really check your assumptions, make sure it works. There's no one model or one R package you can just plug in, it's gonna work. So that has been one of the things that we are struggling with all. One thing I used to work on gender statistics, and it's very interesting how is that linked to air quality, indoor pollution. Women cook a lot in Southeast Asia and some part of Latin America, I think, using solid waste to cook at home. I struggled so much at that time to look for any study that link, there's a sensor that measure the air quality within the household, but there's no data on how much time the women spend on cooking. So the time use element from the survey, they're all separate. So I've had such a huge challenge in bringing those evidence into the models that did the global burden disease on the impact of indoor pollution on women's health. There's very few studies that actually collect those information together. Maybe you can find some empirical study, or maybe there is something ongoing that, since you've been working on air quality, it's the time use element what's the person doing, how much time, and then with the sensor on the air quality. That is so important. I haven't really seen any major study on that.
Thank you, Hao-Yi. Those are really important points. And I feel like with the citizen science framing, there is a lot of steps we can take, right, to get towards this idea of impact, and to not just consider these as general environmental factors, but as really impactful to people's lives and their activities. Luis, I see your hand is up. Do you have a comment that you want to make?
Yeah, thank you. Just very briefly, in this aspect about, this question about tools, I think it's important to also build capacity to understand the standards, to understand the frameworks for that integration, beyond seeing ourselves only as users of ready to use tools. Nowadays, it's much easier for people to develop their own workflows, their own tooling, using simple scripting languages like Python and so on. So that type of work is more accessible, more easily accessible today than it was, say, 3 years ago. And so, as Hao-Yi said, there is no single tool that is fit for all kinds of use cases. So I think we also need to focus on building our capacity to develop our own solutions that align with the standards, that align with the common frameworks. That's the only point. Thank you.
Thank you. Yes, that's excellent. There are so many different avenues, right, that we can take as we approach these problems with air quality and with many of the SDGs. So it's really important to keep in mind things that are interoperable, approaches that are transparent, and that can be reproduced to be able to allow that and facilitate cross-domain methods. So we have a few minutes left. So if there aren't any further questions, I thought I'd just open it back up to the speakers if they have any further comments or thoughts about steps going forward for their organizations, and to leave that with you all today.
So I'll go first. We welcome you to join the Citizen Science Global Partnership Air Quality Monitoring Community of Practice. You can bring your expertise, your network, your knowledge, and then we can expand further on this topic. From there, you will meet a variety of people doing incredible work around the world, and you can see what can be replicated where you come from, what can work where you are that hasn't worked in another place, or you can also bring in new ideas. So Nuria and I welcome you to the Citizen Science Global Partnership Air Quality Monitoring Group. Yeah. Thank you.
Thank you, Faith. If you can add any information about how to join that or connect with that, that would be great in the chat. Simon?
Thanks. I just really like to continue these discussions and concrete collaboration. We have I think we've made real progress on how we implement the FAIR principles and providing guidelines, actionable guidelines in the context of CDIF. As I said, it's not the finished product, but it's a good step in the right direction. So we're really keen to explore how that can be used with citizen science data, with the UN stats data. I think the components of that collaboration are in place. We're just keen to follow it up, to use the task group that we have, the CODATA task group, to use the partnership with the Global Alliance, and to use the collaborations which are represented in this webinar to follow that up. There'll be input from European projects as well, but we're keen to get input from other projects around the world. So yes, how do we build on that collaboration and make this into something real?
Hao-Yi, over to you.
I just
Oh,
text something on the chat. So if you'd like to join the collaborative on citizen data, like email us. Interested in sharing your work, tools you have, exciting news, email us because we have our newsletter so we can share with the broader audience. We are revamping our website, so there will be featured practices or tools web page, and let us know if you'd like to have a feed. We should be able to make this webinar recording available, right? If it's okay with everyone, I'll check in with everyone. PowerPoint recording, feel free to link from your side, Simon and Carolyn. So we'll catch up on that. And we have our Cali EGM expert group meeting 4th in Cali in October, and then we have a one-day learning session during the high-level political forum. It's a hybrid, so welcome.
Great. Thank you so much. And there are so many different ways that we can come together for collaboration in this space. You can also fill out the link, which will go back to the organizers from the chat. I see we have one further question. We do have 2 minutes left, so I guess I will take it. So thinking about whether there's methods that we can agree upon to give real information, give the citizens information of managing their personal health. And I absolutely agree that's a really important question of creating these standards and then sharing it back with the communities so that communities and citizens can actually be active participants and discoverers of their own health risks, and being able to bring that back into policy and community action. So very important point there. So with that, I think we'll wrap it up for today. Thank you so much for your time, for joining this call. We hope to interact with you future in these efforts. And yeah, please stay in touch. Thank you so much.
Thank you. Thank you, everyone.
Thank you very much, everyone. Great questions.
Thank you so much for working together.
Thank you.
Thank you. Thank you.
First time ever these two go one-on-one. Happens live on Netflix.
Oh, there's a video, a game going on.
Oh, where's this? Thank you.
Thank you.